So the circuit breaker is a pattern that helps us in that situation where the service downstream is not responding for a long period of time. So instead of keep retrying the request, the circuit breaker will just interrupt the communication with the service downstream for a while, and then try again a bit later to see if it's back up and running. If not, then it interrupts the communication again. And it works as a state machine. So the default state is the closed state. That is the normal behavior of the system. It means the circuit is closed, so edge service can send requests to book service. But if in a period of time, if we have a lot of error coming from book service, so if that forwarding triggers a lot of errors up to a certain threshold, then the circuit breaker trips and becomes open. When it's open, we don't even try to send a request to book service. So the request is directly rejected. Then after a while, it switches to the half open state. That is a sort of investigation state. So the circuit breaker will allow to send a few requests to the service downstream. If they're successful, then the circuit becomes closed again. Otherwise, goes back to be open. Let's have a look at an example so that we can understand better how it works. So I'll switch branch again. So first, I'm gonna start book service because I want to show you how it works in a normal state. So let's do that. And then in edge service, in order to support the circuit breaker, we have to provide the dependency, which is the Spring Cloud Starter Circuit Breaker Reactor Resilience for J dependency. Really long name. So it's basically the Spring Cloud Circuit Breaker project, which uses Resilience for J as the implementation. You might be familiar with something like Hystrix that is now in maintenance mode, so it's not maintained, supported anymore in Spring Cloud. So Resilience for J is the current library used to implement different resilience patterns, including the circuit breaker, and also provides both an imperative and a reactive implementation. So in this case, we're using a reactive implementation. After providing this dependency, we can once again configure the circuit breaker in the property file, and we can do that through a filter. So in this case, so before I used a default filter, here I want to use a filter specific to the book route. So the name of the filter is circuit breaker. I can give it a name, for example, book circuit breaker. And also, if I want to, I can define a fallback. So this fallback means that when the circuit is open, instead of returning an error, I might define some fallback behavior directly in Spring Cloud Gateway. So in the example of the book service, maybe I can return an empty list of books instead of throwing an error. Or if I cache the previous result, I can return the previous result. So it might not be up to date, but still it's better than failing. So the really important aspect here is that we want to ensure that all our applications keep their availability state. If we cannot guarantee that, at least we should guarantee a graceful degradation of functionality. We don't want to fail hard. So in this case, we want to have a fallback without returning some errors to the user. Maybe with a message informing them that the result might not be up to date, but maybe try again later. And then we need to configure how we want the circuit breaker to behave. And we can do that in Java here. I created a configuration class, And I'm using the customizer object for the resilience for J circuit breaker. The first thing I do here is defining the sliding window size. So this is the number of requests that the circuit breaker will inspect in order to make a decision about whether the circuit should be open or closed. So in this window of 20 requests, if more than 50% fail, then the circuit goes to be open. After 30 seconds, trips to an half open state. And when it's in a half open state, I allow 5 requests to go through. Among those 5 requests, if at least 50% of them are failing, then the circuit goes back to the open state. Otherwise, goes to the closed state. So everything can continue as usual. And then I also configured a time limiter, which is another pattern implemented by Resilience for J, so that for each request, I don't wait more than 1 second in this case. Yeah. So these values now are hard-coded, but of course, it would be better to provide them through configuration properties. You can either define your own properties or bring in a dependency provided by Resilience for J and its integration with Spring Boot so that actually you have some properties that you can use to pass values here. So if you want to customize it further in production or depending on the environment, you can do that. But for simplicity here, I use the Java configuration and hard-coded values. Yes, that's it about the circuit breaker. So I'll start the application now. And I want to point out also that I'm using a second dependency. So one is the main Spring Cloud circuit breaker dependency with the reactive version of Resilience for J, but I'm also using the Resilience for J micrometer library. So this one will extend the Spring Boot actuator behavior so that among the metrics, I also have some metrics specific to the circuit breaker. And in Grafana, I actually have a dashboard for that I'm going to show you now. For basic investigations, I have this dashboard, which presents a lot of different data regarding Spring Boot applications like CPU usage, memory usage, JVM, number of threads, and I have the possibility to check both Edge service and book service. But I also have a dashboard for Resilience for J. Here it is. So Edge service is the application with circuit breakers, but the same library, you can use it also in any Spring Boot application. So it's not something implemented or available only in Spring Cloud Gateway. The only difference is that in Spring Cloud Gateway, you have a filter built in to use a circuit breaker, but the same configuration you can apply to any kind of Spring Boot application, which is really nice. So the application is running, so we're gonna see the values there in a second. Let's make some requests. And is book service running? Yes. Yes, I think I have to increase the timeout here because my machine is really overloaded. You might have some data. Yes. So here you can monitor the 3 states of each circuit breaker. And in a second, I should also be able to select the name of the circuit breaker. There's a bit of delay when Prometheus scrapes the application. But here you can monitor when how many circuit breakers are in the closed state, open state, and half open. Yes, now it went through. So actually, we just seen the circuit breaker working. Well, not really. I guess it was the time limiter. But since my machine is really overloading, it takes more than a second to send the request because of all the streaming software that is running. And you saw that I didn't get any exception. I actually got a fallback result. And where is that defined? I can show you. In the application YAML file, I define here a forward to a / book fallback endpoint in case the request doesn't go through. And that applies not only if the circuit breaker is open, but also if the timeout expires, like it happened now, and it didn't get a response back. And this endpoint, you can define it as you normally do in a Spring application. So you can use either a REST controller or router functions. In this case, I used router function here. So in a configuration class, I define two routes, one for get request to / book fallback and one to post request to / book fallback. And for the get request, I returns an empty result. And you saw earlier that I got an empty response back. That was an empty list. Instead, for a post request, I don't have a fallback, so I just throw a 503 error in a very simple way, but I might do something better here to improve the user experience. So now we can try shutting down book service and see what happens. So I'm going to use a tool. It's called Apache Benchmark to send maybe 100 requests with maybe 2 at a time, concurrency 2, or yeah, let's do 5 to the edge service. Let's see what happens. And then we're going to get more data here as well. Yes. So since book service is not available, the circuit breaker after 20 requests, that was the sliding window that we defined here. So after 20 requests, open the circuit. And you can see that it's in the open state. Yes. Now, for 30 seconds, the circuit will remain open, and then it will transition to a half open state. So first of all, let's start book service again, and then we see what happens after the circuit breaker becomes half open, and we can monitor the status here. So while waiting for the 30 seconds to pass, I want to show you a third dashboard that I have here, which is also useful. And this time is specific to Spring Cloud Gateway. It's used to monitor routes. So I select the application here, and then a route ID that in this case is book route, and select the last 15 minutes. So I can see what happens in my edge service. So this is the time where I didn't make any request, but you can see the number of successful requests and the number of unsuccessful requests and some more details. All this information are provided by the Spring Boot actuator. So we can even check that if we go localhost on port 9000, you can see on /actuator/Prometheus, which is the endpoint scraped by the Prometheus server. You can see all the different metrics that the application is exporting by default, plus the ones from Resilience4j, since we added that extra dependency. Let's go back to the Resilience4j dashboard. So now I'm gonna send one more request. And the circuit should reset at some point. Yes, now it's half open. In this state, I can run 5 requests according to my configuration. After that, it will go back to be open or closed depending on the outcome. Since book service is running, I can run a few requests that will be successful, because yeah, there was more than 5, and the circuit will go back to be closed. So far, I talked about how to make resilient the integration point between the API gateway and all the services downstream. But sometimes you might want to have also some behavior applied at the very entry point. So I'm talking about rate limiters. So maybe you don't have a lot of resources, so you want to prevent DOS attacks, or if you're starting a special offer on your online application for e-commerce, maybe you want to apply a rate limiter so that you don't get too many requests or more requests than your applications can actually handle. Or maybe you want to distinguish between different categories of user. So if you have subscriptions to use your APIs like basic, premium, or plus, then you can use a rate limiter so that for each type of user, they can only send a certain number of requests within a specific period. And about rate limiters, I really recommend reading the article I linked here from Stripe about how to use rate limiters in the most effective way. Once again, Spring Cloud Gateway provides that implementation. It's using the, let's see first, the dependency, because in order to keep track of how many requests each user is sending, we need to save the state. And we can't save the state inside the application because that would make the application stateful, and we don't like that, especially in a cloud environment. We prefer stateless applications. So to have a distributed state available across different instances of the Edge service, we can use Redis, as I mentioned at the beginning. So in this dependency list, I also enable Spring Data Redis Reactive. And I don't have to provide a lot of configuration, just how to contact the Redis container that I have running on my machine, localhost port 6379, and then some timeout here. And then, of course, there's a filter for the rate limiter as well. So all these behaviors are usually available through filters. And just like for the retry filter, I want the rate limiter to be a default filter so that it's always applied. And using the Redis implementation, I can rely on a token bucket algorithm so that each user is associated with a bucket that contains at most 20 tokens. And each second, 10 tokens more are dipped into the bucket. So if we reach the maximum, then we have to wait the next second in order to get more tokens and actually send a request. So each request requires a token to be performed. You probably saw earlier that when I send a request, I get back these special headers in the HTTP response. This is the default behavior of the rate limiter implementation, but you can also remove them. And I can see that in this case, 20 is the maximum capacity. I used 1 token for 1 request, so I have 19 remaining. And once again, if I use Apache Benchmark, I can send 40 requests. with a concurrency of 20. When I apply the rate limiter, the request, if I don't have a token available, then it's rejected directly. So it doesn't go through retry, circuit breakers, nothing there. It's rejected right away. So you can see here that 40 requests are completed, but 20 failed because I used the first 20 tokens, and then since the request was done in like 100 milliseconds, then I didn't get the new group of tokens to use. So after 20, everything else got rejected. In my dashboard, I can monitor that once again in my gateway dashboard for the book route, and I can keep track of all the unsuccessful requests and why. So you can see this too many request error. That's what happens when I don't have tokens left. So at this point, we made our system more resilient with all these patterns, and we have an API gateway that acts as an interface between clients and users and the downstream services. It's time to implement some authentication